how do we achieve rapid progress without compromising the genetic health of our breeding stock for the future?
And the alternative, genomic mating.
Genomic mating directly tackles that. It aims to balance gain with controlling inbreeding. Simulations show it delivering stable gains over many more generations, like 30, while keeping inbreeding in check.
So maybe slower initial gains, but much more sustainable?
That's the idea, balancing short-term wins with long-term viability.
A whole new era of communication in the global aquaculture industry is coming. Now you have the brightest minds in aquaculture right in your pocket. And what's best? You can listen to all of them while driving to a farm, traveling, or running errands. It's never been this good, and it's never been this simple. Welcome to the Aquaculture Podcast Show, the first AI-based podcast in aquaculture, where you'll find cutting-edge insights in everything that's working in aquaculture, nutrition, health, and production.
Okay, let's unpack this. The demand for seafood is really exploding, and that puts just immense strain on our traditional wild fisheries.
It's a classic squeeze, isn't it? And aquaculture has, well, it's had to step up significantly.
It really has, already providing over 16% of the seafood on our plates. But here's the thing that demand. It's projected to increase maybe fivefold.
Fivefold, that's huge.
It is. So this isn't just about farming more fish. It's really about smart, sustainable growth and genetic improvement. It's absolutely foundational.
What's fascinating here is the potential this new approach holds for transforming how we think about aquaculture development. We're really seeing a groundbreaking platform emerge.
A platform.
Yeah, one that's essentially democratizing these advanced genomic technologies, making them genuinely accessible for breeding programs, worldwide. It's like opening a door.
So making these powerful tools easier for more people to use.
Exactly. Ushering in a new era for sustainable productivity, for resilience in these aquatic species.
That's precisely what we want to dig into today.
Why Genetics turns podcast airtime into brand authority. We don't sell ads, we elevate voices. Curious how far your voice can go to become a reference in the industry and attract more leads? Scan the QR code and discover how we can turn your expertise into unmatched brand authority. Let's transform expertise into influence, starting now.
Our mission here is to explore how these cutting-edge genomic tools are being used.
Right.
Not just to meet demand, but to fundamentally boost productivity, disease resistance, environmental resilience, really ensuring long-term sustainability.
Which is critical for such a vital global food source.
So let's just reiterate the scale here. Aquaculture is massive, and that fivefold demand increase means we need solutions fast. But traditional breeding, well, it's always had its challenges, hasn't it?
Oh, absolutely. You've got long generation times for many species. Years sometimes.
Right, waiting years to see results.
And the cost of genotyping, just figuring out the genetic makeup, that can be really prohibitive for many.
And managing genetic diversity, keeping populations healthy, avoiding inbreeding. It's complex.
Very complex. It's often been slow, expensive.
Yeah.
Kind of out of sync with the speed we need now. And this is exactly where these genomic technologies come in. They aren't just, small improvements. They're the answer.
A paradigm shift, really.
I think so. We're seeing tools designed specifically to overcome those old limits. Things like genotype imputation.
Okay, imputation.
Yeah, inferring missing genetic data. Then there's genomic selection, predicting an animal's potential from its DNA.
Right.
And genomic mating, strategically pairing individuals for the best outcomes, both short and long term. They let us move much faster, more effectively.
And there's a specific platform making this happen. You mentioned it earlier.
Yes, the Aquaculture Molecular Breeding Platform, or AMBP. Think of it as the first really comprehensive web server built just for aquaculture genetics.
Okay, AMBP, what makes it different?
Well, a big part is its user-friendliness. Many bioinformatics tools, you need serious programming skills, right?
Definitely. A steep learning curve.
AMBP aims to simplify that. Make these sophisticated analyses accessible to researchers, sure, but also breeders on commercial farms. It's about empowerment.
Putting powerful tools in more hands. I like that.
Exactly. And it integrates a lot. High-quality genetic reference data from 18 key species, fish, mollusks, crustaceans.
18 species. That's quite a range.
It is. And it bundles the core functions. Imputation, population analysis, finding genes linked to traits, predicting genetic merit, planning mating strategies.
The whole workflow, basically.
Pretty much. With automated pipelines, visualization tools, and it works with standard data formats. So ready for real-world use.
Okay, let's focus on one of those features you mentioned, imputation. Here's where it gets really interesting, especially for cost-conscious operations. You described it as inferring missing data. It's like taking a low-res genetic snapshot and turning it into high-def.
That's a perfect analogy, actually. It takes maybe lower density, cheaper genetic data and computationally boosts it to high resolution.
Which lowers the cost barrier significantly.
Hugely. Makes advanced analysis feasible even without huge budgets or expensive high-density arrays.
So how accurate is it? Can you trust that inferred data?
Great question. The reference panels are key, built from whole genomes of nearly 2,300 individuals, identifying over 144 million genetic markers.
Wow.
And validation tests show really high accuracy, concordance over 0.92 for most species. If we connect this to the bigger picture, this imputation capability significantly lowers the barrier to entry for advanced genetic analysis.
Right.
It opens doors for species where maybe those high-density commercial tools just don't exist or way too expensive. It really does level the playing field.
That's fantastic. Leveling the playing field is crucial. But it's not just about boosting traits, right? We have to protect the genetic health of these populations.
Absolutely essential. Understanding the genetic structure, the kinship who's related to whom, is paramount.
Why is that so critical?
Well, mainly to avoid accidental inbreeding. That can really hurt fitness and productivity down the line.
Makes sense.
It's also vital for just managing overall genetic diversity, keeping the population robust, adaptable, and, for researchers, tracing domestication history.
So you need tools to see those hidden relationships.
Precisely. And the platform provides them. Things like principal component analysis to visualize genetic groups, add mixture models for ancestry, and tools to calculate specific kinship values, identify how closely related individuals actually are.
Can you give an example?
Sure. Take Pacific white shrimp. Huge industry. The platform was used there, and it successfully identified 7 distinct ancestral lines within commercial stocks.
Aligning with their known breeding history.
Exactly. And crucially, it could distinguish closely related individuals. If you miss that, you might inadvertently increase inbreeding when you select breeders.
Undermining the whole program long term.
Right. It's about seeing those connections for sustainable breeding.
Okay, so we've got this incredibly detailed genetic information thanks to imputation and analysis. Now, how do we use it effectively for breeding? You mentioned selection and mating strategies.
Yes, genomic selection and genomic mating. And this is where breeders face a strategic choice.
A trade-off.
Essentially, yes. How do you balance getting rapid genetic gain now, fast improvements, with ensuring the population stays healthy and diverse for the future? It's a crucial balance.
So tell me about these two strategies within the platform.
Well, the platform uses advanced model statistical machine learning to predict an animal's genetic merit, its breeding value, very accurately.
Okay.
Now, genomic selection. It's great for accelerating gains quickly, but the risk over time, say 10, 15 generations, is you might deplete diversity, increase inbreeding too much.
Leading to potential declines later on.
Potentially, yes. This raises an important question. How do we achieve rapid progress without compromising the genetic health of our breeding stock for the future?
And the alternative, genomic mating.
Genomic mating directly tackles that. It aims to balance gain with controlling inbreeding. Simulations show it delivering stable gains over many more generations, like 30, while keeping inbreeding in check.
So maybe slower initial gains, but much more sustainable?
That's the idea, balancing short-term wins with long-term viability.
Let's make this concrete. You mentioned Pacific white shrimp before.
Yeah.
How did these tools help there?
Well, beyond identifying those lineages, the detailed kinship analysis allowed for much more accurate genetic evaluations. For a species worth, over $26 billion? Precision matters.
Absolutely. Any other examples?
Atlantic salmon is another great one, often seen as a model for genomics in aquaculture.
Right.
The platform showed it could accurately impute from lower density data, around 10,000 markers, up to high density, nearly 80,000.
Showing its power even with less initial data.
Exactly. And genetic studies revealed complex traits like weight are polygenic, influenced by many genes. Prediction accuracy was good, over 50%, even after imputation.
And the breeding strategy comparison.
Clear win for genomic mating and simulations there. Sustained gain over 30 generations, better long-term health compared to just selection.
So the platform really helps compare those long-term outcomes. Now, how does this AMBP stack up against other tools out there? Is it unique?
Its big advantage is that dedicated aquaculture focus. It's not a general tool adapted, it's built for aquaculture.
Purpose-built.
Right. And it integrates the whole pipeline, imputation, analysis, prediction, simulation. It's more of a one-stop shop.
Compared to maybe stringing together different tools.
Exactly, which can require more expertise, more steps.
Makes sense.
And if we connect this to the bigger picture, AMBP isn't just a research tool. It's a practical, accessible resource that can truly empower breeding companies globally.
By lowering the barrier to entry.
Yes, reducing reliance on specialist bioinformaticians, accelerating adoption of these powerful molecular breeding techniques. It even helps generate figures for reports, streamlines workflows.
Making advanced genomics much more approachable.
That's the goal. It's about practical impact.
So what does this all mean for you, for the listener, and for the future of food? This platform, AMBP, feels like a really critical milestone.
It is. It's part of the genomic era for aquaculture.
It's not just about faster growth. It's smarter, more resilient, more sustainable growth for the whole sector, which is vital as that global seafood demand keeps climbing.
We need these scientifically advanced but also responsible ways to meet that demand.
Absolutely.
Yeah.
This Aquaculture Molecular Breeding Platform seems like a genuine game changer, improving genetics, supporting sustainable production.
And maybe a final thought for you to consider. How might platforms like this not just optimize specific fish or shrimp, but fundamentally reshape our whole approach to global food security, bridging that gap between, cutting-edge science and taking care of our environment, building a more resilient food system for everyone?
If you enjoyed this episode, make sure to follow the Aquaculture Podcast Show on your favorite platform. And don't forget to follow us on LinkedIn, Instagram, and Facebook to stay updated on the latest episodes and industry insights. Thanks for tuning in, and we'll catch you next time.